Okay, this should be the solutions to your first review quiz. On number 1, it tells you to let f be a function given by, and you see your function, for which of the following values of x is f not continuous. So we do need to remember what it means for f to not be continuous. And we would not be continuous at values to where we had a hole in the graph or where we would have a vertical asymptote. So that would be something good for us to remember. So the first thing we need to do is look for a hole in the graph. And that's going to be where we factor and cancel. That does generate holes in our graph. So let's look and see. This looks like it's already factored for us. So let's see if we can cancel anything. And it looks like we can. And when we cancel out our x minus 2's, notice on top you have x minus 2 times x plus 3. And then in the denominator, you're going to have x plus 1. So we know here we've canceled out an x minus 2, and we always set that equal to 0 to see where exactly would that x value be. And so we know at x equals 2, we have some kind of hole in the graph. So when we come over here, then that eliminates A and eliminates C. And so now the next thing we need to do is look and see, well, what about for a vertical asymptote? So if we look for a vertical asymptote, that's where we're going to set the denominator equal to 0. So x would be -1. So here I have a vertical asymptote at x equals 1, and then this was a hole in the graph at x equals 2. So it looks like my two places where where f is not continuous is at D, -1 and 2. Okay, number 2, find the instantaneous rate of change. That's going to be what we call IROC. So instantaneous rate of change. So we need to find the derivative of f of x. So we have f prime at x equals 3x squared minus 12x plus 8. And then we need to find this derivative value at 3. So we're going to plug in 3 and see what we get. So we get 3 times 3 squared minus 12 times 3 plus 8. And so let's see, that's going to be 27 minus 36. So that's going to be what, -9 plus 8. So it looks like we get -1. So the right answer should be C. Okay, number 3, we needed to find over what intervals is G decreasing. Over what intervals is G decreasing? Well, when G is decreasing, G prime of x, or the derivative, is negative. So let's see, what does G prime of x look like? So I do the derivative. I get x squared plus 3x minus 70. And I would go ahead and find my critical points, or set that equal to 0. And it looks like we can factor this, and looks like we're going to get a positive 10 and a negative 7. And when we set all this equal to 0, x is equal to -10 and x is equal to 7. And we can do a number line analysis, or we can look at the graph. We have x squared, and we see that this is a parabola crossing at these two values at -10, and we're crossing at 7. And if I want to know where my derivative is negative, then graphically that is talking about where we are below the x-axis. And notice we are below the x-axis between negative 10 and 7. Okay, number 4. We need to go ahead, and I would always try to plug in first before we do anything else with a limit, because this might work out nice and neat. Chances are it's not, but I would always take our problem and I would do a plug in. And let's see, if I plug in the top, I get 2 squared plus 2 minus 6 over 4 minus 4, and that's going to give us 0 over 0. So we have talked about L'Hopital's rule now. Since we've got 0 over 0, we established that's the limit. Now we can redo the limit, but let's look at what happens as x approaches 2 of the derivative. So we're going to take the derivative of the top, and then we do the derivative of the bottom, and now reevaluate your limit. And so you're going to have 5 in the numerator and 4 in the denominator. So it looks like your answer choice should be D. Okay, for number 5, this is a particle motion problem. And let's see, we're reading through, let's see, the graph intersects a horizontal axis at t equals 0, t equals k, and t equals m. And notice we're told that it intersects and has horizontal tangents at J and L, so that means I have a horizontal tangent here and here. And so let's see, for what values of t is the speed of the particle decreasing? Well, let's see, speed, how is speed and velocity related? Well, speed is the absolute value of velocity. So what we can do is turn this graph of velocity into a speed graph by flipping over all that's negative. So from k to m, that's below the x-axis, so we could really do a rough sketch and move this up, and now we have speed, the graph of speed. So looking at this, where can we tell that speed is decreasing? Over what intervals? Well, from here to here, speed's decreasing, so that's from J to K. Well, that's not A, it's not B. Well, notice that C is the only one that has from J to K. And so, looks like it's going to be C, but I would double check from L to M just to be sure. And if we notice here from L to M, we are also decreasing. So C is the correct answer. Now number 6, a lot of times on number 6, people miss this because they think about L'Hopital's rule and think that, hey, I can just take the derivative of the top and bottom and be done with it, but we can't. This is going to have to be your quotient rule. And so after we find the quotient rule, then we'll plug in 3. So my quotient rule, we need k prime at x equals, we have our bottom function times the derivative of the top minus the top times the derivative of the bottom, and it's all over bottom squared. So all over g at x all squared. Oop, needs more parentheses in there. Okay, now we need to plug in our 3, and make sure when you do k prime at 3, that's where you're plugging in. Don't put in 3 up here or you're going to miss a free response problem. You'll miss points doing that. So we need to see g at 3 times f prime at 3 minus f at 3 times g prime at 3 all over g at 3 all squared. Now let's look and see, what is g at 3? g at 3 from the chart is 2 times f prime at 3 is 5 minus f at 3 is -1 times g prime at 3 is -2, and this is all over g at 3 squared. So g at 3 is 2, 2 squared is 4. And so let's see, I end up with 10 here and minus a positive 2. So it looks like, let's see, 10 minus 2 is 8. 8 over 4 is 2. Okay, so for our function g, we need the absolute minimum value, and notice I'm over a closed interval. And for that absolute minimum value here, so we need the smallest value that's going to occur over the interval from -2 to 1. So we know a cubic function is going to look something, now this is just going to be a rough graph, but it looks something like that. And so our minimum value, since that's a positive, is really going to occur somewhere back over here if we're talking about from -2 to 1. So we do need to check though and see where this curve is. So let's go ahead and do the derivative and find a critical point. So g prime at x is going to be 12x squared plus 6x minus 6. And again, this is a factoring situation. We need to set this equal to 0, and I would factor out a 6 out of every part. So I have 2x squared plus x minus 1. And when we factor this, let's see, we'll have 2x and x, and we need a positive 2 to, when I multiply through, and a -1. So I have x equals a half, or x equals -1. Now let's look at our values that we need. We are looking for the smallest value for this function over this interval. And when we start looking at those values, we have g and we have g at x. Well, what are the candidates or x values that I can plug in and see what the smallest values are? Well, always your endpoints. -2 is an endpoint, 1 is an endpoint, and then any critical point you might have. So 1/2 and -1. Now again, from reasoning here, if this function is looking something like this, then the further left we are, really that's going to be the smallest value, because I'm pretty sure this is a nice cubic function here. So I would pick this value right here and plug in. So g at -2 equals, and notice I'm plugging in g because I want the minimum value of that function. So let's see, 4 times, well, -2 cubed is going to be -8 plus 3 times -2 squared, and -6 times -2, positive 12, and then plus 1. Excuse me. So g at -2 equals, well, let's see, that's going to be -32 plus 12 is 24 plus 1 is 25. And so notice -32 positive 25 is -7. Since I want the minimum value and I got -7, there's no other answer choice smaller than -7. So I've already found the absolute minimum. Now, if for some reason that -7 wasn't there, or I got a different number, then I would have tried -1. Then I would have tried 1/2, and then I would have tried 1. So do keep that in mind. Okay, the very last problem. We're given a graph of g of x, and we need to find h at x is defined here, and we need to find h prime at x, not h of x. So let's see, what would h prime at x even look like? Well, we need the product rule. So we have the first times the derivative of the second plus the second times the derivative of the first. Derivative of e to the x is e to the x times the derivative of x, which is just going to be 1. Now let's plug in our negative 1 and see what we get. So we have e to the negative 1, g prime of negative 1, plus g at negative 1 times e to the negative 1. So h prime of negative 1 equals, well, g at negative 1, or g prime at negative 1, that's going to be the slope of the line connecting here, because we know this line here is tangent because it told us down here that that is the tangent line. And again, from when we very first started talking about derivatives, that was the whole idea, that this was the slope of the tangent line at negative 1. So if I look at my rise over run, so we have, let's see, negative 3 minus 3, so negative 6. So I'm going to do my slope here. So I'm going to get negative 6 over 0 minus negative 1. So that gives me negative 6. So I have negative 6 over e, because that negative exponent means reciprocal, plus g at negative 1. Well, that's just this ordered pair right here. So g at negative 1 is 3. So I have 3 over e. And now we can combine our like terms, and I have negative 3 over e. So my correct answer should be B.